this. Okay, so what you're seeing here is that you're seeing that we started talking about Rutherford's planetary model. So when you look at everything that I have right here, note that you could write it if you want, but note that it's right here already, right? I already just came in and I just copied this and I put that under. So just so you know that you don't have to necessarily write this because it's already there. And the only reason why I did that is just to try to keep, the same type of, thread going for this lecture, because we're talking about models of the atom. So we were starting to talk about Rutherford's planetary model of the atom. And what we said here is that the big problem is that any electric charge that accelerates emits electromagnetic radiation. And since the electron is going around in a circle in the planetary model, it's always constantly losing energy by emitting radiation. So to give you a sense about this, we started talking about the microwave. So microwaves have electrons that move in circles. And as they move in circles, they are emitting microwave radiation. So if the electrons in the microwave were not connected to the outlet, that is the power plant behind PG&E, the electrons in the magnetron would lose energy, and as a consequence, they would crash into the walls of the magnetron. So picture-wise, even though I just said it here, I'm going to repeat this just to make sure that this is real clear, because this is an important point. And this is why Rutherford instantly knew that there was a problem with the planetary model back in 1910. So again, if I look at this thing, I have my magnetron, right? So this is my magnetron. And what you're seeing here, just like I drew the picture up here, remember that this is, they're circling as well as wiggling. This way they accelerate more and therefore they emit more radiation. I'm not going to draw in the wiggles here. So what you're seeing here is that the electrons in the magnetron are going around in a circle. So I look at these electrons and I can look at them at different places. And the only reason why I'm doing that is just to remind you that these guys are changing velocity. And as they change velocity, they are accelerating. As a consequence of this, what do? They radiate radiation. So this right here is the emitted radiation. In this case, the radiation is microwaves. So again, just to review, even though I just set it up here, we then say that the reason why electrons continue to move in circles is the added electrical power from the outlet. And what that does here, this means here is that the electrons are constantly re-energized. Right, they're constantly regenerized, and so that means that they don't crash into the walls of the magnetron. So they don't crash into the walls. So then, what do I mean by this? If there was no added electrical power, not add, but added, the electrons would spiral and crash into the walls of the magnetron. So picture-wise, we could see the following thing here. So there's the spout that's emitting microwave radiation. And maybe this is what I should be doing here, is that here's the radiation entering the microwave. But now let's look at the path of this thing. So what you're seeing here in this path, what you're finding here is that the electrons, they're moving in the circle here. So as they're moving in the circle, the first thing they do here is that they emit radiation. And as it emits radiation, what path does the electron do? Well, it loses energy. So as it loses energy, its path is now shifted. I think that's a little bit too much. So instead of going in a circle, it's now going into a smaller circle, but it continues to radiate because it's still moving in a circle. So then what you're seeing here is that you get this constant radiation, and as a result, you're seeing that this thing just spirals, and then boom, it crashes right into the walls here. So it's constantly emitting energy in the whole process. So what we're seeing here is that the constant emitted radiation, electrons lose energy. And that's what Rutherford said. He knew that. Anybody who has studied physics, even back in 1910, knew that electrons accelerating would emit radiation. And this was one of the biggest problems in understanding the atom. And if you look at Einstein thought that this problem would never be solved, that it was too hard of a problem. So here we go. So in the Rutherford's planetary model, orbiting electrons crash into the nucleus within 10 to the negative 8 seconds. So in other words, in 0.1231231 second, right? So orbiting electrons crash into the nucleus within 10 to the negative 8 seconds, and the atom stops or ceases to exist anymore. There is no more atom. It doesn't exist. So I just typed in atom and I said, okay, here's an atom. And look what they tell you, right? This is a very, 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 very standard picture. Look what you see right here. Look at this. Electrons are orbiting. That's what this picture means, right? This is a common image of an atom. And it's a bad model. It's a bad model. So what we find here is that in summary, standard physics, and believe it in this case, it's actually Newton's laws. Standard physics is Newton's laws cannot describe, describe the behavior of an atom.